This video was brought to you by the ILC. Hello there once again. Welcome back to our Exam Review 1 series. This time we'll be doing Problem 15, Part 3. We are given two functions. The first function is fx, which is x divided by x plus 1. The other function is gx, which is x to the third power. Our first task is to find the domain of those two functions. Let's begin with function f. We see that fx is a fraction, x divided by x plus 1. The rule for fractions is that the denominator cannot equal 0. Therefore, we can say that for this function, our x plus 1 cannot be 0. If we subtract the 1 from both sides, we'll end up with x is not equal to negative 1. We can draw a number line to represent this domain. We place our infinities on the left and right, and we place an open circle at negative 1. This open circle will split the domain into two pieces, A and B. So we have two pieces in our answer. We'll have negative infinity to negative 1, union negative 1 to infinity. This will be the domain for function f. Now for function g, we have no fractions and no roots. Therefore, on function g, there are no restrictions. Because there are no restrictions, you can automatically answer negative infinity to infinity. There will be no need to draw the domain here either. The second part of this problem is to find f plus g of x, f minus g of x, and f times g of x. To find this, all we need to do is replace the letter f and the letter g with the functions that we defined earlier. So for the first problem, f plus g, we'll write x divided by x plus 1, and then add function g, which is x to the third power. To simplify this function, we can look to the denominator and remind ourselves that we have x plus 1 on the bottom, so our least common denominator here would be x plus 1. So we can place both x plus 1 on the top and the bottom and combine the two fractions that we have here. Before we do that, let's multiply the x to the third times both of the terms inside the parentheses. We will have first x over x plus 1 for the first fraction, plus x to the third times x, which is x to the fourth, and then x to the third times 1 is x to the third, also over x plus 1. If we combine these two fractions and add them together, we will have x to the fourth plus x to the third plus x. Simply put all the terms that are in this numerator together above the bar. Below the bar, we keep the same x plus 1. This is our f plus g of x. For f minus g of x, we do the same operation. We take function f, which was again x over x plus 1, this time subtract the same thing, x to the fourth plus x to the third over x plus 1. I will caution you, be sure to include your numerator in parentheses, because this subtraction will be applied to both the x to the fourth and the x to the third. So our answer will be negative x to the fourth, because of the negative sign will be applied to the x to the fourth, and then also minus sign will be applied to the x to the third. So we have negative x to the fourth, negative x to the third, and positive x, still over x plus 1. This will be our f minus g of x. The f times g will be a little bit less complicated. To take f times g of x, we just multiply the two functions together. x over x plus 1 times x to the third. We only have to multiply the numerators together, so we will have x to the fourth, because x to the first times x to the third gives x to the fourth, over x plus 1. This is our f times g. And that is how you find these three composite functions, f plus g, f minus g, and f times g. Thank you for watching. We'll see you again soon.